Hello guys, in today's video I'm gonna go over limits of trigonometric functions, like how to find the limit of these functions. So before we solve any problems, I'm gonna go over limits of some basic trigonometric functions which will be very useful or helpful to solve the difficult problems. Okay, so first of them is the limit of sine theta when theta approaches to 0 is equal to 0, because when you plug in theta 0 over here, sine 0 is 0. And the limit of cos theta when theta approaches to 0 is 1. And this one is very useful, used in so many problems. So limit of theta approaches to 0, sine theta over theta. Remember, this angle need to be same, or this value need to be same. Then the limit is equal to 1. And same thing for the tangent. Okay, the limit of tangent theta over theta as a limit of theta approaches to 0 is equal to 1. And same thing over here. And when you got sine of theta minus a over theta minus a, and this theta is approaching 0, the limit is 1. And same is true for tangent. So try to remember these basic limits, then you'll be able to solve the other problems easily. Okay, so in today's video I'm gonna go over plenty of examples. I'm gonna show you what example I'll be solving today using these formulas or these basic limit values. Okay, so I'm gonna go over these three over here and a couple of these, this one, this one, this one. Okay, so these are the examples I'm gonna work on today. Alright, so let's start with the easy ones. Okay, so these are the basic limits of some trigonometric functions. Try to remember them. Alright, let's go over the first one. So this one says limit x approaches to 0 cos x over pi minus x. So in this case we're just gonna plug in the value of x is equal to 0. So that gives me cos 0 over pi 0 over pi minus 0, and that is basically 1 over pi, as cos 0 is 1. And in this one, see, let me show you. So you see sine theta over theta, whatever is the value over here, we want the same value in the bottom denominator. So in this problem we got 5x over here but x in the denominator. So what we can do, if we multiply and divide it by 5, that will solve the problem. So we're gonna say limit x approaches to 0. So I'm gonna multiply by 5 and sine 5x and divide by 5 over here, which gives me 5x in the denominator, and that gives me, I'm gonna take 5 out of limit. So limit x approaches to 0 sine 5x over 5x. Or if you can do substitution over here, let's say if I say let's say 5x is equal to u, that means if x approaches to 0, u approaches to 0. So I can rewrite this as a limit u approaches to 0 sine u over u is equal to 5 into 1. Okay, you can leave it like this too, but still gives the same answer because this constant multiplied by 0 gives you the 0. Okay, so sine u over u as u approaches to 0 is 1. So answer is 5. Alright, let's do this one. In this case we got limit x approaches to 0 sine ax over sine bx. So see, we got sine in the numerator and we got sine in the denominator. So what I'm gonna do, I'm gonna multiply and divide. Gonna multiply by ax and ax over here. Same thing I'm gonna do for denominators, bx. So I want bx in the denominator, gonna multiply by bx over here. So that tells me, as you know, the limit of this value as x approaches to 0 is 1. Okay, so that gives me ax in the numerator, and same thing, limit of sine bx as x approaches to 0, again 1, and that'll leave me bx in the denominator. Again, you can you can like make a substitution, ax is equal to u, and then u approaches to 0, but it's the same thing. So when we solve it, this gives me limit of this function is basically a over b. Okay, let's work on next problem over here. So there is like two different ways to solve this problem. I'm gonna do the easier one first, and then you can do the other one too. Let's go over this one. So limit of 1 minus cosine x over x square as x approaches to 0. So I'm gonna use a trigonometric identity over here. So limit x approaches to 0. 1 minus cos x is basically equal to 2 sine square x over 2, okay, and divided by x square, and which can be written as, I'm gonna take 2 out, a limit x approaches to 0, and we're gonna separate this to 2 sines, because you see there's a sine square, x over 2, in the denominator we got x square, or we can write it like, we can write it like this too. So x over here and x over here. Okay, so then 2 limit x approaches to 0. See, this is x over 2, this is x. So we want x over 2 over here. If I want x over 2 over here, I need to multiply by 2 over here. Okay, so that means sine x over 2. So x over 2 into 2, right? Same thing for this one. Write limit x approaches to 0, and we can say sine x over 2 divided by x over 2 into 2. All right, and that gives us okay, so that gives us 2. 2 times 2 is 4, and the limit of sine x over 2 is basically 1, and same thing, the limit of sine x over 2 as x approaches to 0 is 1. And again, if we want, we can do like do the substitution as x over 2 to u as x approaches to 0, then we're gonna say u approaches to 0. Okay, and we can plug in u over here, will give us the same answer. So when we solve it, this gives me 1 over 2. So the limit of 1 minus cos x over x squared is basically 1/2. So that's one way to do to solve this function using trigonometric identity over here, like 1 minus cos x is equal to 2 sine square x over 2. Or if you don't remember the trigonometric identity, then you can solve it other way too. I'm gonna do that method too. Okay, so how we can solve it without using identity. So limit x approaches to 0. I'm gonna do the conjugate over here, 1 minus cos x, remember as we were doing before, plus cos x over, we got x square into 1 plus cos x. Okay, and limit x approaches to 0. So a minus b into a plus b is equal to a square minus b square. All right, so this can be written as 1 square minus cos square x over x square into 1 plus cos x. Okay, and the limit x approaches to 0, and we know 1 minus cos square x is basically equal to sine square x. Cos x. Okay, so we got we're gonna separate this into 3 different limits. So limit x over sine square x can be written as, sine x over x, and then limit x approaches to 0 gives me another sine x over x, as I'm breaking it down into 2. Okay, into limit x approaches to 0, 1 over 1 plus cos of x. Okay, so this gives me 1, and this gives me another 1, and this part gives me 1 over 1 plus 1, which is basically 1 over 2. Again, we got the same answer, 1/2. So like there's different ways to do this problem. So they can be asked you like 1 minus cos 2x over here, which is same problem, just 2 there. You solve it, but the answer for that problem will be 2 because of this 2. That 2 will play a factor over there. But for this one, it's 1/2. But if they ask you 1 minus cos 2x over x squared, approach the problem the same way as we did this one. All right, let's work on next one. So this is 7x cos x minus 3 sin x over 4x plus tangent x. So if we see over here, we can divide the numerator by x and the numerator by x. So that'll solve the problem immediately, I believe. Let's see how. So 7x cos x minus 3 sin x. I'm gonna do in steps, over x, divide 4x plus tangent x over x, right? And this x can cancel with each other. So limit x approaches to 0. So in the numerator we got 7 cos x minus 3 sin x over x, because this x will cancel out this x. And in the denominator we got 4 plus tangent x over x. And when we solve the limit as x approaches to 0 for cos x is 1, so we got 7, and limit of sin x over x as x approaches to 0 is 1, so we left with 3, and over here we left 4, and limit as x approaches to 0 tangent x over x is 1, so that gives me 4 over 5. All right, let's do a few more examples. So this one says tangent x minus sin x over x cube. All right, let's simplify this first of all. So limit as x approaches to 0. I'm gonna write tangent x as sin x over cosine x minus sin x over x cube. Okay, and it can be written as limit x approaches to 0, and the numerator becomes sin x minus sin x cos x over x cube into cosine x. Okay, and so rewrite it. So if we can take sin x out because it's common factor for both of them, so gonna take sin x out, so left with the 1 minus cosine x over x cube cosine x. Okay, and now we're gonna write the limit. Sorry, forgot. Limit x approaches to 0. So limit x approaches to 0, we can write it as sin x over x. I'm gonna break down this x cube into x and x squared. So first part we got sin x over x, and then we got 1 minus cosine x over x squared, okay, into 1 over cos x. All right, so limit x approaches to 0, sin x over x into limit x approaches to 0, 1 minus cos x over x squared into limit x approaches to 0, 1 over cos x. So the limit x approaches to 0 sin x over x is 1, and I'm not going to solve this problem again. If you remember, this looks like our previous example. 1 minus cos x over x square. So limit of this is 1/2. So I'm gonna write it just 1/2 there, as we already solved it. Okay, so the limit of this function is 1/2 into 1 over cos x is 1 over 1. So this basically gives me 1/2. So that's the answer for the limit of this function as x approaches to 0. Okay, let's go over next. So cos 2x minus 1 over cos x minus 1. So this problem again can be solved in two different ways, but the easiest way is just to plug in the trigonometric identities. Okay, and the other way is, writing multiplying by conjugate and solving it. I'm gonna try to solve both way. Let's solve it using the trigonometric identity first of all. All right, so cos 2x is basically equal to 2 cos square x minus 1. Okay, or 1 plus cos 2x is 2 cos square x, and we can rearrange it. So instead of cosine 2x, I'm gonna plug in this trigonometric identity over there. Okay, so limit x approaches to 0. Instead of cos 2x, I'm gonna plug in 2 cos square x minus 1. Okay, then we got this minus 1 over here. In the denominator we got cos x minus 1. All right, so limit x approaches to 0, 2 cos square x minus 1 gives me minus 2 over cosine x minus 1, which is equal to limit x approaches to 0. I'm gonna take 2 out as common factor, so we're left with a cosine square x minus 1 over cosine x minus 1, which can be rewritten as, so remember, a square minus b square is a minus 1, a plus 1. So cos square x minus 1 can be written as cos x minus 1 into cos x plus 1. So in the denominator we got cos x minus 1. Okay, and these two cancel out, and we're left with 2 limit x approaches to 0 of cosine x plus 1, which is basically 2 into 1 plus 1. 2 into 2 is equal to 4. So the limit of this function is equal to 4. So that's the one way to do it. Let's do the second way. I'm gonna try to do the other way too. Okay, so limit x approaches to 0, so cos of 2x minus 1, and multiply it by its conjugate, cos of 2x plus 1. Okay, and same thing here, cos of x minus 1 and multiply it by the conjugate plus 1. But we can't write them like this. We need to, if we are multiplying here, we need to multiply it in the numerator too. Same thing for this one, cos of 2x plus 1. Okay, so this is a minus b, this is a plus b, a minus b, a plus b. So we're going to use those identities to rewrite them. So the top can be written as cos square 2x minus 1, and the bottom, the numerator, can be written as sine square x into cosine x plus 1 over cosine 2x plus 1. Okay, so cos square 2x minus 1 is equal to basically minus sine square 2x, and we got sine square x over here. Sorry, what did I do? I jumped one step forward. Okay, so this can be written as cos square x minus 1. So this can be written as a minus sine square x cos x plus 1 over cos 2x plus 1. And you know how I get this? So you remember sine square x plus cosine square x is equal to 1. So if I take 1 over there, and if we subtract 1 from both sides and minus sine square x from both sides, this gives me cos square x minus 1 is equal to minus sine square x. So that's what I used over here. Instead of cos square x, I wrote minus sine square x. And when it is 2, just put 2 there. Alright, let's solve it further. So minus minus cancel each other, gives me plus. And what I'm going to do over here, so limit x approaches to 0, sine square 2x over 2x, right, into 2x, divided by sine square x over x into x. Okay, and remember this is a square here. Okay, so this is not going to be 2, going to be 4 here. So I'm gonna put 4 here. Okay, because I need to write in 2 different values for this. I'll show you what I mean. Okay, so this still the same, cos x plus 1 over cos of 2x plus 1. Let me find some space over here to solve it further. What you'll get the same answer. Okay, so I'll show you why I did that. 4x. Okay, so limit x approaches to 0. Now you see sine 2x over 2x into sine 2x over 2x. See, so I break down this 4x into 2x, and this x will cancel this x, so we're left with only 4. I'm gonna write that 4 over there, into, we got limit x approaches to 0 of cosine x plus 1 over cosine 2x plus 1. See the second part. And we all know the limit of sine x over x as x approaches to 0 is 1. So 4 into 1. Same thing for this one, 1. And over here we got 1. The limit of cosine x as x approaches 0 is 1, plus 1 over 1 plus 1. So this gives me 4 into 2 over 2, which is again equal to 4. So we got the same answer as we did as we solved this problem using trigonometric identity, other than doing the conjugate. So if you see, this method is a little longer, so the other one is short and fast. So that's why I always recommend to remember the trigonometric identities. So that makes your life much easier when you're solving these problems. Okay, but this takes some time. Alright, so these are the 2 different ways to solve the same problem. Let's work on the next problem, which is square root of 1/2 of 1 minus cos 2x over x. So here I'm going to use again the same trigonometric identity. 1 minus cos of 2x is equal to 2 sine square angle over 2. So angle is 2x. So 2x over 2 just gives me x. Okay, so we're going to plug in that value over here. So we got limit x approaches to 0, square root of 1/2 into 2 sine square x over x. So this is basically equal to limit x approaches to 0, and 2 cancel out with the 2, we're left with square root of sine square x over x, which is equal to limit x approaches to 0, and we need the absolute value of sine x here, because square root of any number gives me positive and negative answer. Okay, so now we're gonna see the limit from left hand side and right hand side, as we got the absolute value of a function here. So let's say So now I'll say limit as x approaches to 0 from right of sine x over x with absolute value. As x approaches to 0 from the right hand side, that means all the values of x are positive. That means sine x is positive, so the absolute value of sine x is just sine x over x. Limit x approaches to 0, this gives me 1. Now if we look into this from left hand side as x approaches to 0 from negative side, okay, so sine x over x. So what it should be? It is going to be limit x approaches to 0 negative minus sine x over x. I'm going to tell you why. Okay. So as it's approaching from the left hand side, that means x is less than 0. Therefore, sine of x is less than 0. So that means the absolute value of sine x is going to be negative of sine x. You know why? Because the sine x is negative. So we need to put extra negative there. So when this negative value multiplied by this negative value gives me positive value, as the absolute value of any function is always positive. Okay, let me write the easy thing over here. So if x is less than 0, right, let's say x is negative 2, that means according to the absolute value functions definition, the absolute value of this x, if x is less than 0, is a negative x, right? And you can see negative, and x is a negative 2, so multiply by negative 2 gives you positive 2. See, the absolute value function is again a positive. That's what we are trying to do over here. Okay, as sine x is less than 0 in this case, as we are approaching from left, so absolute value of sine x is going to be negative of sine x. Okay, so we get negative limit x approaches to 0, sine x over x is going to be negative 1. So as right hand side and left hand side limit does not match with each other, so the limit of this function does not exist. Okay, you need to pay extra attention to these kind of problems. All right, let's do a couple more. So this one is cotangent 2x minus cosecant 2x over x can be written as limit x approaches to 0. First of all, what I'm gonna do, I'm gonna make it easier or simpler, you know. So cotangent x can be written as cos of 2x over sine of 2x, and cosecant x can be written as 1 over sine of 2x. That's the basic trigonometric identities over x. So this is equal to limit x approaches to 0. We're gonna solve it, and that gives me cos of 2x minus 1 over x into sine 2x. Okay, and I'm gonna rearrange this, so this can be written as limit x approaches to 0 minus 1 minus cos of 2x over x into sine of 2x, because I want to use the trigonometric identity over here. That's why I rearranged it and took the negative out. So that gives me negative limit x approaches to 0, and 1 minus cos 2x is basically 2 sine square x over x, and sine 2x is equal to 2 sine x cosine x. So that is another trigonometric identity. I'm gonna write both of them over here. 1 minus cos of 2x is equal to 2 sine square x. So I'll say flashcard idea, flashcard. The second one is sine 2x is equal to 2 sine x cosine x. Again, flashcard, you can remember those identities. So that gives me this 2 will cancel this 2, okay, and one of the sine will cancel this sine over here, and sine x over cosine x, so negative limit x approaches to 0. So sine x over cosine x gives me tangent x over x, and we all know from the basic limit of trigonometry, as we saw on the first page of this video, so limit of this function as x approaches to 0 is 1, and we got negative there, so negative 1. So that's the limit of this function over here. Okay, so we got the last problem, very interesting problem over here. We got limit x approaches to 0 sine x degree over x. In all these problems, starting from here, this angle here is in a radian, okay, but in this problem we got this value in degrees. So first of all, we need to convert this degree into radians, okay, and how we gonna do it? Okay, as we know, because 180 degree is equal to pi radians, right? And also 1 degree is equal to pi over 180 radian. And if I multiply by x, so that gives me x degree is equal to pi x over 180. Pi x over 180 radians. That's what we're gonna substitute over here. Instead of x degrees, we're gonna write in radians. So this can be written as limit x approaches to 0 sine of pi x over 180 over x. So as we see, we want the same value in the denominator as we got in the numerator with the sine. Okay, to do that, limit x approaches to 0 sine of pi x over 180. So as we multiply x with pi over 180, so we need to do the same over here too, right? And the limit of this function, or we can say pi x over 180 to u as x approaches to 0, u approaches to 0. So I'm gonna do the substitution over there. So that gives me pi over 180 into limit u approaches to 0 sine u over u. Okay, the limit of this is equal to 1. So we got pi over 180 into 1. So answer is pi over 180. Okay, so that's how you can solve problems like this. So this can be used as a standard formula too. So limit of sine of x degree over x, just pi over 180. Same thing we can solve for tangent x or any other function. Alright, thanks for watching the video, guys. Please practice more examples to get better at these problems, and please share with your friends and subscribe to the channel so that you won't miss any other videos. Thanks for watching. Have a good day. Bye bye.